So this is, my, what is this? This is a project video for my solids of revolution with respect to a vertical line. How do you spell revolution?
You're cracking some joke.
I'm not cracking a joke, I forgot how to spell, okay. Keep it on the paper.
It's on the paper.
Alright, so anyway, your formula is going to be found on the outside, integral from A to B.
Can you pick up that book, please?
Big R squared minus little r squared, and then dx. So, it's the same, essentially, as with respect horizontally with respect to the x-axis, so the y-axis. So let me think of a practice problem real quick. Do y equals this x squared. I don't know, we'll do y equals square root of x. And y equals 1. And then we're just going to revolve around the y-axis. So, you graph it. It's going to be 1, it's going to be 1, and y1 is obviously going to go across like that. And square root x is going to start up plus 1 and keep going. So that's the intersection. Josiah's currently laughing, just ignore that. So y equals 1. Alright, so your integral is going to be from 0 to 1 because you're revolving around, x equals 0, which is right here. So you're looking for this shaded in part. And in order to isolate that, you're going to kind of take it like it's in respect to the x-axis, even though you're revolving around the y for this, because your top is going to be 1 in order to get this part. That's going to be your big R. And your little r is going to be square root of x, because you don't want anything underneath it here. So I'll just leave you with that part. So for big R, so y equals 1. Little r is y equals square root of x. And the integral is going to be from 0 to 1 on the outside. Now you need to set your equations equal to y because you're rotating in respect to the y-axis. So it's going to be y squared equals x, and still just y equals 1. So your big R is going to be y squared, and your little r is going to be 1. And you can plug that in, y squared minus 1 squared dy. And you're going to plug that into your calculator. Pause it.
I can't pause it.
Oh. Well, it turns out we don't have the graphing calculator in class. But in the calculator, you're going to replace the y's with x's, and it'll give you the same answer.
Becca, you know how to use a graphing calculator?
Do you have a graph calculator, Becca? Alright then. Well, that's going to be tough. So you plug that in your calculator, and it will give you the answer, whatever that number would be, and you're going to add pi to it, and then boom, that's the answer. So now, we're going to do it when it's rotating around an axis other than 0. So we'll do y equals square root of x, and y equals x, and it'll be from x equals, we'll say x equals 0 to x equals 1, and the axis it'll be rotating around will be x equals 2. So you're going to graph it first. It's going to be x. Alright, that there. And y equals square root of x. So you're trying to get that little area in between the curve there. It's very small, I know it's hard to see, but this is going to be your axis. Since you're rotating around 2, it's going to have to extend another 1. So it's going to go to 3. It's actually going to start at 4 and then go to 3. And that is going to be the shape. No, it doesn't extend that much. My bad. Right. You don't need to go to 4. You need to go to 3 and then draw it to 2. It's going to be 1 off. And it's still going to be the same thing.
Don't for me, this shit's too complicated. I don't know this shit.
Alright, so anyways, you got that. It's going to be rotating around 1. So this is 1 away. Oh, it's rotating around 2. Oh, I see what I did. I accidentally got confused. That's why I thought it was right at first, because it was right at first. I marked it at 1 even though I wrote 2. And my mind went blank for a second. But that's okay. So the way I had it was correct. The side's cracking up in the background. Let's just ignore that. We got our shape. So we're going from the y-axis out to 2. And we're trying to only get this little sliver right here. So our big R is going to be, since we only want that little sliver, and square root of x is the big one, we want everything under that. We're going to have square root of x minus 2, and our little r is going to be 2 minus x, because we want everything but the x, and we got to make sure we take care of this whole 2 part right here. It's circulating around it. And then you got to set that equal to y. So you're going to have square root of x minus 2 equal to y. This is going to give you y squared plus 2 equals x. And you're going to have y equals 2 minus x, which is going to just leave you with y plus 2.
Is that it?
No.
No?
No.
I don't know.
No. I see what I did wrong. You're supposed to set the y's equal to it before you add the 2's, or subtract the 2's. No, don't laugh, cuz.
Come on, instructor.
Alright, instructor. So, your big R is going to be y squared minus 2. And your little r is going to be 2 minus y. So you're going to set up your integral, put on the outside. Your a to b, it already told you 0 to 1. So it's from 0 to 1. Big R squared, so y squared minus 2 squared minus 2 minus y squared. Okay. I'm more nervous because I don't have the calculator, so I can actually show what the answer is. And it's going to give you a certain number times pi, which is your answer.
Cool.
So that's how you take your respect to y when they change the axis on you. I think those are the only 2 examples we need to explain it.
Cool.